Welcome to the IB Physics revision series on the Hesabu Lab channel. So this first playlist focuses on HL Paper 2 past paper questions since they tend to be the most challenging. And the goal of the series overall is twofold. The first objective is to utilize past paper questions to build your problem-solving muscles. Confucius said, I hear and I forget, I see and I remember, I do and I understand. I am a firm believer in building problem-solving skills through, you guessed it, practicing problems. So the unique approach this series takes, however, is to build those skills on a solid foundation. By this, I mean identifying the overarching topics and subtopics within the questions presented, then giving a brief lesson on the theories and concepts pertinent in the question in order to build a clear picture of the mechanisms at work. Okay, and the second objective is to illuminate the links between several topics by tackling questions with similar integrated topics. For example, this first playlist will focus on past paper questions that integrate the concepts of mechanics and electricity. I believe that using this approach will build a deeper conceptual understanding of the ideas present in the physics syllabus. This is because an integrated approach is more accurately reflects the world we live in. Okay, that is a world where we use electricity or electrical energy, mechanical, and heat energy simultaneously or sequentially throughout our days. Okay, so that is where we wake up in the morning and turn on our lights and use, pop some toast in the toaster and use fuel and a motor to get us to work or school. Okay, since this series focuses on paper 2 questions, I thought it would be prudent to have an overview of the exam and the IB Physics examiner's expectations. So generally the paper 2 paper carries the most weight out of the 3 HL Physics papers, and that is a weighting of 36%. The HL exam itself has a duration of 2.25 hours and usually consists of short and extended response questions. Now, the number of questions on each paper is approximately 8 or 9, and the number of points per question ranges from 7 points to 15 points to give a total of 95 marks. Okay, calculators are permitted, unlike on the paper 1 exam, and use of the physics data booklet is required. Of course, owing to the breadth and depth of topics on the physics syllabus, it is absolutely necessary to have a general list of formulas and constants, right? So IB examiners are, of course, just looking for your ability to reason scientifically as opposed to your ability to memorize astronomical numbers. Okay, and finally, just back to the second point there, the questions on paper 2 cover assessment objectives 1, 2, and 3, which are expounded on in the syllabus, but I will give an overview of these objectives on the next slide. So now let's look at the assessment objectives covered by the physics paper 2 HL paper, as well as the SL. And there's three main objectives that are usually externally assessed, and these are also included in the biology and chemistry, or they are also applied to the biology and chemistry syllabus. So the first one is to demonstrate a knowledge and understanding of facts, concepts, and terminology, methodologies and techniques, and communicating scientific information. So in a more simplistic uh, view, you could say that this is, you can think of the definitions and the theories and the laws that perhaps you are required to know. Perhaps, for instance, Newton's laws, Newton's first, second, and third laws, the concept of gravitational potential energy, and kinetic energy. And then, so, just to get just a basic grasp of those concepts, okay, and their definitions. And then the next thing is to apply those concepts, right? The facts, concepts, and terminology, and also communicate that, okay? And then, so then the next one would be to formulate, analyze, and evaluate
hypothesis, research questions and predictions, methodologies and techniques, primary and secondary data, and scientific explanations. So objectives 2 and 3 are kind of you could say that they're sort of one and the same thing in some ways. So when we're saying that we want to apply and then evaluate, so when you are applying this concept, perhaps of Newton's second law, for example, you should know that the net force is proportional to the acceleration of an object, right, and inversely proportional to its mass. Okay, so then when you have a question that asks you, perhaps you have an object on an incline. So in order to answer that question, what is the net force acting on the object on that incline? You should be able to apply uh, the use of a free body diagram, for instance. You should be able to use that. That would be a method of communicating scientific information. And then from that, be able to evaluate all the forces that are acting and then come up, use that second law. So figure out what are the vertical forces, the horizontal forces, and then the net force in either direction, and then answer the question, is the block going to slide down the slope or not, if there is friction or if there's no friction involved, that sort of thing. Okay, so that's it in a nutshell. Okay, so but we will look at the examples. Once we go through the examples, then this will become a lot more clear.